Hi, everyone, and welcome to the concluding part of our Hackaday project on Spark integration and analysis with a NoSQL database we chose as Cassandra. In the first part, we looked at Cassandra as a highly available and linearly scalable data source that is, according to DB ranking, the most popular wide columnar store. We also took a very broad exploratory look at Cassandra. We talked about how it works, why it is considered highly available, and also having very tunable or flexible consistency feature. We also concluded that Cassandra has quite a number of use cases in our enterprise, amongst which is using it for data sets that are very large volume data sets, using it for enterprise systems that have very huge write demand, and systems that would prefer a very highly available data store, even if they have to sacrifice a little bit of consistency. And we talked about what that sacrifice really means. Then also another use case is when you're having a very geographically spread out data centers, and because of the high availability and the ability for Cassandra to choose the servers that are closest for write and read request. So for cross data center distribution, we looked at is also you can use it to store a lot of metadata for static files. So having made these decisions, we looked at a little bit at data modeling and went on to talk about the use case that we have at hand, which is the UK's Ministry of Transport vehicle testing data. So we had three questions, and one thing we stress in Cassandra modeling is that it is really guided, or modeling is governed by the read request. We always show bias to request when we model our data, because of the insane speed you get when you do write, and the read part is a little bit more complex because you have a lot of caches to go through, key caches, row caches, as well as one other cache, bloom filters as well. You need to check with the MAME stores before the MAME stores bloom filter. You go into the index caches, then finally get to the SS tables. Right, that is not the case when you do write, because when you do write, you only visit two places upon reaching a node, which is the commit log and the commit log and the memory table. Writing into memory tables is considered the fastest you can get, and writing into an append only commit log is also super fast, because there is no file seek. You don't look for a point in the file to add, you just add it. So we made all these descriptions, and by the way, we also took a look at where we continued from the last Hackaday session, where we took a look at MongoDB. So it means in this session, we will conclude the requirement of our queries in one hand, and we will look at modeling from a different perspective like we did MongoDB, and we will run the query, we will write our Spark application and write them to a Cassandra database and try to run that query. Meanwhile, we ran a particular query last, and let's see, I think I can make this bold enough. We can look at all our key spaces, and we were working with, is it moving this key space? Use describe tables. So it looks very close to what we're used to having. So I think I used the wrong key space name, but it's okay. That's just the name. Then we want to see, let's just check out the number of records we have in the test item details. From test item details, and we ran this and got a complaint, even though we have 12,000 500, we said that we are not using a partition key, and we explained why that error is. Because whenever you're accessing data in a Cassandra database, it expects you to get a row key so that it can know which of the nodes in the ring will participate in that query. But in this case, we are just counting everything we have, so every node is participating in that query. Literally, we're telling every node to give me a number of records they have in them, and that is why we have that warning. So we completed these, and we had it in our rough notes. So let's see exactly what we did. We only focused on the lookup data. Remember when we downloaded the data, we downloaded two sets of data. We downloaded two sets of data, and let's see. And that is the test item and the test results. Everything we just worked on right now is the lookup data. And the idea is that we had some sample queries from the website we are trying to mimic, and we started with this, where we are trying to get the basic expansion of the reason for refuser hierarchy for a certain class. So when we looked at this query and we modeled for this query, we decided that we were going to have a primary key of test class or and reason for refuser ID, that's RFR-ID. So we modeled these, but using the functionalities we have in Spark, we literally denormalized these to get the 5 levels. And we saw that this is the query that did that denormalization, and it turned out that it worked absolutely well, exactly what we expected, and we wrote the data into Cassandra using the Spark Cassandra connector from DataStax. It makes the API very high level and very easy to use, so that you can do things like writing data frames to Cassandra and reading Cassandra records into Spark as data frames. By the way, this is from DataStax, and it is full featured. Like, you cannot get this. Is awesome, right? So we've used the high level APIs, and everything wrote cleanly for us, so we were able to run the queries that we expected from Cassandra. So let's look at the query. So this is the query we wanted to run. We wanted to see this, right? But first of all, let's take a look at what this table looks like. We can say describe this table. Okay, so that's a test item details. So for those who use this in a Linux environment, you can tab. I mean, there's a tab functionality that makes it easy if you don't know what to write. But it turns out I don't get that benefit when I use when I do it on Windows or when I use this shell, right? But if you tried, say, an Ubuntu in CentOS Red Hat, you can just type describe and you tab, and you're gonna get the code completion feature. Okay, but we don't have it now, and it appears we don't really need it. So we decided to make the test class ID as the primary key, right? And the reason for refuser ID is the clustering key. So data is going to be arranged in partitions. Rows are going to be arranged by partitions, and the partition key is going to be test class, right? And test class is going to be the partition. Then within a partition, they will be ordered by the reason for refuser key, right? If you want to see how it looks like, for instance, we can say, let's say select star from the table, quite a big table, test item. This is where I need that, right? Where test class ID is equal to 5. Let's just see if we can get 10 records. Invalid integer. Now, sorry, test is 5. This should be 5. Good. So we got 10 records. If we kind of brought it down, should have been more. But let's do something like this. Expound on and we run the same query, but this time I want to see how it is written, so I just want one. This is the way the record is written, and it's just important that I show you this, right? This is how we're looking at one record. If we wanted to look at two records, you'd see it like this. This gives you an idea of how records are written in Cassandra. So let me make a little note about that. The first thing you see that is we'll have the partition key. Every role has a partition key. So you can say these guys are in one partition, right? There's a partition key. Then within that partition, they are arranged lexicographically by the RFID, the clustering keys. You can have one or more clustering keys. So you can see that 10001 is greater than this, right? Then every other thing goes in as the column. Now we have different types of column. We have static columns, and we have static columns, and we have non-static columns as well. So the columns in the column families, right, which we also call tables, are arranged in the order of lexicographical, in the lexicographical order of the column names. So you can see, even though when we created the table, if we look at the create table, we yeah, is it this exact? No, let's go to the query statement. Let's go to our DDL. When we created the table, we said DDL, right? Test ID came before minor item ID, minor item before RFID, and these were the last. But when we read the query, you can see I's came before M, before R, before T, right? So it kind of like it reordered your columns, right? That is what we can assume. It reordered our columns based on the names of the columns, right? Cool. So I just wanted to show you the way that looks like. We can expand off and run the same query, and you can still see the same thing happened, but you get how it looks like. First, you have the partition key, which tells you all this row we just read are in one partition. So basically, the read is going to be pretty fast, even though it goes to the SSDs. So, and this is why modeling is a very modeling is literally like the key to this whole stuff. Okay, so we have concluded with this query. Let's see a lot more that we can do, and we're now going to look at our aggregate queries. These are the lookup tables. So let's see what we have with the other queries. So when we looked at this, which is pretty simple, we want to model data for these and by the way, this is the key space I intended to use, not movie lens. But you can get it in the code, and you can just do the same. So remember, we have two main entities. We talked about a test result, which contains all the data for every test, every vehicle test. Then we have another table called test item. By the way, let's take a look at it. UK dataset. So we have, nope, this is wrong. So we have a test results which contains all the outcome of every test, whether good or bad. Then we have test items, which contains the failures, right? The failures of test results. So if a record passes, right, that data would not exist in test items, because test items only hold, it's actually called test failure items, right? It only contains failures, right? But you know, in Cassandra, there are no joins, so we can't join the two tables trying to find out if something passed or failed. So how are we going to store this data? Let's just think of first how we're going to store the data if we originally just want to store it as is. So how we get the data, we store it. So we also remember that this is what the entity diagram looks like. This is from the relational world, and we had these table joins and test data table joins, and all we have solved for so far is test item and item group. We matched them in together. We explained these self-join hierarchies, and we got level 1 to level 5 hierarchies for the test item groups. Now we can decide on one hand to model test data to just be the way it is, so that somebody can issue a simple query like, get me the test, get me the test with a particular test ID. That's the simplest of all. Then we can also model data to say, get me test by vehicle. So you want to see the history of a particular vehicle ID. We're working with 1 year's worth of data, but you can want to see a test across many years. And also, you still have these date range queries. So we can literally say, let's see a test for a particular date range, right? So we don't know how we're going to model the data until we know how the data is going to be used. So what I did first was just do that plain vanilla test to say, we can model the data by test ID, right, as a partition key. And you can also then put all these other columns as clustering keys. But this in itself, if you look at a particular use, let me tell you why this I wrote, but this is kind of wrong, or wrong in a context. Remember, it's when you find how you're going to use the data that you will actually know whether it's right or wrong. So wrong is not a good word in modeling, especially in Cassandra. It's the kind of usage that determines if something can be better or not. So let me tell you why this will not be better. Number one is that if we say we want to make the test ID a primary key, but remember, the test ID is totally unique. Totally unique. So if the word sounds fair, we know that there will be only one test ID ever in existence. So within that test ID, you can be clustering this. That's what I'm trying to say. Within that test ID, we cannot be clustering this because there will only be one record ever in that partition. That means the partition will be small, will be easy to read, but we could do better. It's the idea. Let me explain again. Within a partition, you can have many rows that are ordered in the order of their clustering keys. For example, in the last model we saw, we had test ID, test class ID, right, 5, and within it we had like many. So let's do something like this. We have one partition, test class ID, and we have RFR ID. So we might want to say, if we look at the test ID 4, we want to see how. Let's just look at 50. So you can say within 4 we have this number of RFIDs. So this is one lookup. I mean, everything is definitely gonna be in one node because the partition key, right, helps us find the node, right? We take the primary key, we look up the node, which will with the muml hash the partitioner. We try to find out which node in the cluster, or which nodes in the cluster have that record by looking up the primary key, right, and creating a hash value for it, getting a token, and it will know which nodes have the code. I mean the data, as the replicas of the data, and it will use the snitch feature to know which of this replica is closest to the coordinator node, and which is the coordinator node is the contact point for the user, right? So which of the nodes did you connect to, right? And it will use that node closest to the coordinator to fetch this data. So you can see this is going to be like pretty very easy for Cassandra. And also this is one partition, right? This is one partition, right? And within that partition there is an ordering. However, this could lead to a particular problem, having too much large a size of partition. As a matter of fact, there is a limit to the number of cells that a partition can contain, and there is a recommended limit. Let's just do that. Cassandra limit to size of partition, right? And there's a limit to, for performance purpose, there's a limit to you're advised to stay within a limit of the size of a partition, right? So you model to make the data to make sure the partition stays within a particular size, and you also model to make sure you don't have just something very flat that is not efficient for you to look up. However, let's put it this other way. If we assume that this is the only way the data will be used, where it will only be searched by test ID, then this is appropriate. So once again, it is not wrong, right? If that's the only way it's going to be used, then it's appropriate. But if that's not the way it's going to be used, then it is not appropriate. Okay, cool. So let's look at the query that will guide us. So we will try to do something better than this, but let's first take a look at the queries we have at hand. This time we have a real analytical query. The query says select the test class. So we're trying to find the initial and the complete test volume of class 2009 to 10. And you want to group it by the test results. Now this is going to be test ID test results. Good. Test ID test results. So what does this mean? We are going to do quite a number of where clauses, right? We're going to do quite a number of where clauses. And if we take a look at it, for this analytical query to work, we need to do something and do it fast. The first thing we will notice here is that we don't have test ID. So this cannot be your primary key. And if you wrote a table like this and you try to run this code, it's going to fail because we should see that in action. So this is what I did right here. So I did test ID primary key. So let's create this table and let's put action to words here. Cool. So we literally created test results based on this definition. Now let's try and run this query. The idea is it's going to fail for some obvious reasons. Good. The reason is that the primary key test column cannot be restricted. Preceding column test date is restricted by a non-equality relation. So let's explain that. So guess what? Our query says that we're testing by test type code. But if you look at our table definition, you find out that test type code is a clustering column, right? And this clustering column in itself is preceded by a date, right? So we have a problem here. That means let's rewrite this query to make sure that date comes after. So you can see even the ordering of the clustering columns affect. Yeah. So let's move things around. So I am going to take test type code and put it somewhere here. But if we do this, we're still going to run into the same problem because you have test results. So I'm going to take test results and put it here as well. And so let's run this again. Right? So we copy this guy and we paste this guy and we get another error. So the error this time is that the test type code cannot be restricted. Okay, so the test type code, okay, we get the same error. And the idea is that the test type code is being restricted by the test date. So changing the query did not help us at all. Changing the query did not help us at all. Okay, so what do? We can decide to drop the table. And so we drop the table and just first of all agree that this did not work for us, right? This did not work for us because the way our primary key is ordered, we are now looking for other things that our primary key is ordered in a way that it doesn't really help us to do what we want to do. That is very, very clear. And also we can see that let me remove this ordering. Okay, so based on the ordering, if we return the ordering, we see that that table just doesn't cut it for us, right? Number one, let's explain what this error means. What this error means is that we are actually testing by a value where in a clustering column where the preceding value has a wildcard. That is what it means. So that means we have a wildcard here, but you are testing by this. If we go to the other table that we have used, you would see that same possibility. So let's say test describe, right? So imagine if we said that we are searching by test item ID. That's gonna be a problem, right? So give me a second. Where RFR ID, let's try RFR ID. This is 100, I think was it 01, I can't remember what we did the other time. Look at it right here, is that you cannot execute this query as it might involve data filtering and thus might have unpredictable performance. Now remember, RFR ID is a primary key member, right? But if you look at this, it's a primary key member, but it's a clustering key. So when Cassandra takes the value, it doesn't know which node to look at because the actual partition key is missing. It's wildcard. Let's use that word. So it means it needs to visit every single node and every single partition to find all the partitions and look at the clustering members of all the partition. That is why it's telling you you're going to get unpredictable performance. Now we can force Cassandra to do that, but it's not advisable to do that. I can say allow filtering. So literally do that. Allow filtering, do that. So, and that is what I have done. So you can see how the modeling really affects what we get. And coming from a relational database management system background, for me, this is not even acceptable. I don't feel very comfortable with this. And that is why as Cassandra engineers, it is the design of the query is the primary thing. It's as primary. It is the success of the project. If you're going to use Cassandra as your backend, it is the design. So you can see we just can't go looking up anything we want. Let's see test item ID. Where is it? 1000. If I couldn't get this done, definitely I can get test item ID. Test item ID. So if I remove allow filtering, I'm not getting this done. I'm not getting it done because invalid string constant. Is it a string or an int? Sorry, it's an int. Sorry. Good. So once again, you get that you're trying to filter. Another thing you can do if you had this problem would have been to create an index. So literally, I can create an index on this table for this column. Create index on. Now I need IntelliSense right here, or else we can. Give me a second. Yeah, let's use mine. Create index on table, then we put the column specifier. So they call these create indexes. Create index, what would that be? on test item details on, sorry, and then we use the column specifier, create this on tests item ID, sorry, on test item details. Then I'm gonna put test item ID. Right, so let's hit this query again. Now we get a value. So the value was 100, so now we get a value, right? So stuff like that. So you can see where we used an index, you can also drop that index. So these, but you can imagine when you start creating a lot of indexes, when you see yourself start creating so much indexes, once again, your model design wasn't good enough. Good. Okay, so let's go back to this query. What can we do? And this is on test results. This query is on test items. So let's focus on test results. The first thing I can think of doing to model exactly for this query is to say, what are we going to call this table, this initial completed test volume? I can create, this is it, a table specifically for that analytics. So I'm going to do something like this, create table, let's see, what's the name again? Test volume. Test volume by class and outcome. So I'm just going to say class and outcome. So see what's going to happen here. Just to make it easy for me, I want to copy this and put it in the same page. I don't want to flip between pages. So what this is going to mean is I'm going to have this as a text, then test result, I want to be sure what I'm doing. Test result is a text as well. Test result is text. Then I could have test date, right? Because there's test date right here as date. Then I would have then if I need any other property, I could go for that, right? So probably would just copy and paste all this. Test type, let me just copy and paste all this. So this is test type code, test result code. So this is test result code for me. I think they're the same. So flat this out. So we have test ID. Take this out. So I'm gonna have vehicle, text mileage, postcode area. So I'm like literally restructuring that table. Test ID. So I'm gonna put test ID somewhere. It's not necessary though. So once I get here, my primary key will now be test class ID, right? And what's the other guy? Test. Okay, there's a test. Sorry, what am I doing here? So there is a, let's just look at that query once again. So we have test type, and sorry, I was supposed to do test type. I was supposed to do test type. It was test type, not test results. Got it wrong. So this is tests. Gonna come here. Gonna put this down, and this is still text. So this is test type. So I already had it here. Okay, so this is text type 1, and the next one is test type and test results. So I'm going to take test result code right here, And for this sake, I'm gonna make this a joint primary key, right? So anytime you want to write a query, you have to provide both of them. And the other let's see, tests class IDs, just gonna follow up. For now, I'm just gonna leave it at this. Test class ID. This is ordering. You can order as much as you want. So now within this, you can also add with clustering. So literally adding, you can say with clustering order, I want to order these, for example, I want to order in descending order or ascending order, right? You can say, so this is the primary key. Now within that primary key, you want to order the records by the test date. This is going to, now what's going to be, there's going to be a problem with this, and I'm just going to tell you, there's actually a formula that you can use to calculate if you, what you think the size of the record is going to be, what the size of the record is literally going to be. Because you want to imagine if this is my primary key. Now just imagine that this is my primary key, right? And I'm putting all the records. Now 2005 records alone is 7 point something million records. Now imagine when I put 2017, which is hitting over 10 million records, I'm going to be growing the size of the partition just too large for what it was supposed to be. The size of the partition as data comes. Now this Cassandra is supposed to hold trillions and trillions of record. My partition will become too large. Now what you want to do in that case is do the concept of bucketing, where I will then add something called a year month. So I restrict the size using year months. Year months is just a way for me to now reduce the size of the partition so that a partition containing the same test type code and test result will only hold for a single month, right? And in that way, right, if your data will be still too large for year month, then you want to bring in probably a year month date. But remember, if you do that, right, your queries is going to differ, because now you have to specify the test type code, you have to specify the test result, and somewhere in between here you have to specify the year month. So year months will span between here and this, right? You have to add it to that query, right? Where it's now, you have to add it to the query. So what I just did in Cassandra is called bucketing. You are, and for those who have done Hive in our different hacker days, you understand what we're trying to do, right? Bucketing is when it's something you do to improve your Hive query when your partitions will be too small, right? If you use partitions, it will be too small, so you use bucketing. It's almost opposite in Cassandra. It's when our partitions will be too large, so we want to narrow the size of the partition down, because there is a limit to how large the size of a partition could be. So that is it. So I'm just gonna take this query, we're gonna save it and try to run this again. So we have create table, right? We have create table, unknown definition, test type code. Let's see that test type code. Oh, sorry, I had two of it. This was supposed to be, okay, let's just take this out. But let's see what the error is. Referenced test type code, test result code. Let's take this. Cool. So let's see if we get that complaints from this guy. Cool. Unconfigured table test results. I'm sorry. So this will be test result outcome. So we should change the tables we're looking up here. Good. So now we get another step. Group by currently supports only columns following their declared order in the primary key. Okay, so what happened here is we said group by test results. And what is test results? Okay, group by test results and test results, and we had test result code here. So we're gonna have this, and so we should have added this. Crazy, right? So let's say drop table cool paste. So you see, I write a query, I don't even load data, and I test. I write a table, I don't even load data, and I test the query immediately against it. So once we've done that, let's see if we pass. No, I think this is still gonna fail because I didn't take care of what it asked me to do. So yeah, I literally did not take care of it. So I'm testing by grouping by. Let's see, group by is only supports a group of columns following their declared order in the primary key. So we wrote test class. Okay, let's do something. Let's break this query down till we'll get where the bottleneck is. I'm just gonna take out this first, and I'm gonna take out the group by. Right, so I'm gonna break this query down and see, copy, and good. So it works. So like we passed the primary key test. Now we want to get the aggregation test. Good. So the aggregation test comes in when we said select count. So if you run this, definitely if you have this, you should have a group by clause, right? So you should have a group by clause. We don't have that group by clause, but let's now bring in the group by clause right here. So we want to group by test ID and result test. Okay, so this could mean two things. It wants to group by test ID and result test. So the first thing we want to do here is, so where will test ID be? Should test ID be in front of the test date, or should it be after should it be after the results, the test date? Now let me explain. So remember, we're using the test date for filtering. For ordering. So given our clustering order, we are saying, right? We are saying that we want to perform efficient range queries once we have used our primary key. So this is going to be an implementation of a range. Now remember, I said we could have done better because in a reproduction this will not scale because our partitions will be too big. So the error we get in here is saying that now I'm grouping by something, and what I'm grouping by, I'm not following the order in the primary key. Now, what would be the order? The order would be doing something like this, right? Even though I don't like it, but we know it is trivial because this column and this column are almost the same thing. Remember from the design we implemented, they are literally the same. So it is redundant. It is redundant. But we're gonna try this. So, oh sorry. We're gonna run this. I'm just gonna run everything at once, so we don't have to copy many times and paste. Unconfigured. Sorry. Missing clustering order for test ID. Okay, so when we said, okay, remember we said this was descending, but we did not say ascending or descending, right? So we could, I could do without this for now, right? I have bigger fish to fry, so I could do without that for now. Okay. Good. So we get another error, and this is where it gets really painful. It says that the primary key test date cannot be restricted as the preceding column test ID class cannot be test dates cannot be restricted as preceding column test is not restricted. So it's saying that, hey guys, you gave this guy a wide card, and that's true because they are not in our where clause, and you are using this as a where clause. So we run into another problem. So bottom line, what's the problem? And I am going somewhere with this. So we say, okay, yeah, wildcard, what can we do? We bring it back, then we're exactly where we started. We're exactly where we started. Now, I'm just going to be frank. This is for only one query. And remember, you can decide to write this query in many ways. So literally, I could have taken test data and put test data in front. Test date in front, and I would have destroyed the model. And that is one. Number two, from experience, you cannot control the way the client writes the query. You just can't. So what does this bring? This tells you that in the area of ad hoc query analytics, we seem to be so disappointed in Cassandra. So that means, you see, I'm writing a query testing that the query would work, not perform, would work in the first place. It has to work first. So does it mean that Cassandra is not built for analytical queries? The answer is yes. Yes. I mean, literally, you can take this to the bank. So when Cassandra was built for fast writes and fast write of transactional applications at web scale, not for analytics. So we're not even looking at how to use the data. So how we're going to do analytics, I don't know. Let's take a look at it first. So it's used for fast writes, and you can see it's giving us exactly the fast writes that we need. Are you getting what I'm trying? It's giving us exactly the fast writes that we need. It's used for fast write, but for ad hoc analytics, how does Cassandra intend to do it? And that's what we're doing. It uses the other big data start platform with which it works very well with. And one of such example is Spark. Right? So when it comes to real ad hoc data churning analytics, remember when we created this table, we did not assume that somebody can ask a question that they actually want to write a query based on the make. And this is what happens in production deployment of Cassandra. Many times you have to keep multiple copies of the same data to support different query patterns. Right? You have to do that many times to support different query patterns. But in this case, as you can see, we are imagine if we have in this case 20-something records, and you know in your different jobs you've dealt with tables that have over 60, 70, 100, and in some cases, extra cases that I have seen, about 600 and 700 columns. How do you actually establish what's going to be? How do you actually establish how the client is going to query that data? I mean, you're going to pack everything into, remember, even if you pack everything into the clustering columns, you still have to differentiate the order. So that is why you had this diagram. And you see, I'm trying to prove by work that we're trying to score this guy to even work. Right, I think I should save this. Modeling analytical query trial. We are trying to try it. SQL, cool. So we're even trying to try it. We're trying to get it to work, but we are having that bridge. And this is just half. What if they said group by make and model? Group by, I mean, there are a number of columns that we could literally try, and we are not even that close. So what happened is we're gonna see that integration Spark and Cassandra, and we want to run So we're going to use this. This is what we initially did. Remember, I told you, not very nice in my opinion, but let's just see, because this, assuming this test was an Internet of Things application, you literally, now that is where Cassandra is, excels, because you'll be streaming in these applications. You'll be streaming in these writes, right? Cool. So we've done this for test results, and what I just did to show you the thinking pattern will also apply if we're doing the test item. So it comes to test item, you will want to make that decision. Should this be primary key? No, you don't want to use dates as primary key. Doesn't make any sense to do that in this kind of domain. So you want to move this query down and determine if this all will be your primary key. And what will all, should 4 of them be your primary key? What if somebody searched with something else? I mean, you're going to go through all those questions that we just asked and we'll still not get a good answer, because we will go through the same thing that we just did. Should the group item levels be should it be now the primary key with all these guys, or should it be a clustering key after these guys and this guy? We're going to hit the same brick wall within them. I don't want to go through that because that will be time taking. So what happened? So what I did was, and that is why I resorted to this plain simple table that literally doesn't have much of intelligence into it, because I just want to assume that I'm landing the data and I'm going to delegate all my analytics to Spark, right? So once again, you have to use the query to create the table. That is, you have to create the table for the query, even if you have to duplicate the data set in different tables. That means you're going to have vehicle ID, test result by this, test result by that. You're going to have duplicates of the table. In the Cassandra world, it is very permissible. But the idea is, where we get from experts is, try not to make it more than 3. I mean, you don't want to duplicate it in 12 places. That's right. And now the question you want to say, I want to touch on this, so it makes complete sense. If you duplicate the data, does it mean I'm going to write the data multiple times? The answer is yes. You're going to write the data multiple times, but you can create your own kind of transaction to make sure it's all or nothing. And the feature in Cassandra that allows you to do that is called batch. So before you write it multiple times, you open a batch, you end the batch, or you like kind of cancel that batch. So it's either everything gets written or nothing gets written. Remember, you will incur some little performance penalty in the write, but because of the super fast nature of writes, it turns out that it's something that is very, very acceptable. Just to give you an equally fast read. I mean, it's something we can afford. So, having had the MongoDB experience in the last Hacker Day, you want to go back to those videos and check out that video and see we didn't have to think this much. You will see Cassandra brings a whole new way of thinking, where we literally have to drop everything we've known. But we're right here, and we will take a break after this, and in the next we will take this, our simple naive design, write it in and see if we can achieve what we could not achieve by trying to change the way the table looks like to support that query, right? So let's take a break, and when we come back, that will be it.